This video is on parametric equations and rotation of graph. And so in this video I use rotation of graph to generate images like these. And so here we have a rectangular equation of an ellipse center with the center at h, k. And I want to find the corresponding parametric equations for this ellipse. Recall that we have sine squared plus cosine squared is equal to 1. And if I let sine of t be x minus h over a, and then cosine of t be y minus k over b. And then notice that we have sine squared plus cosine squared is equal to 1. And so the corresponding parametric equations with the center at h, k, will be x equal to h plus a sine of t. So here, right here, solve for x. And then right here, solve for y. Then we get y equal to k plus b cosine of t. So here's an example. Here I have x is equal to 6 plus 4 sine of t, and y equal to 6 plus 2 cosine of t. And then here's the graph. And so internally, I used JavaScript to generate the points right here, x, y, for this graph. And now what I want to do here is I'm going to rotate this ellipse with the center of rotation at the origin right here. And to rotate this ellipse counterclockwise, then we have these formulas right here. And so x, y would be the points on this ellipse, and then x prime, y prime would be the points on the rotated ellipse, and then theta here would be the angle of rotation. And the center of rotation once again is at the origin, and so here's angle of rotation is 5 degrees, and so we get all of these rotated ellipses. In a lot of applications, the rotation needed to be at a center of rotation that's different from the origin. So for example, here I want the center of rotation to be at the point 6, 6 instead of at the origin. Now to get the ellipse to rotate with the center of rotation at the point 6, 6, then we have to modify these formulas a little bit. And then this is how I modify these formulas for the JavaScript program. And so these are the modified formulas that I'm going to use. And then here the center x, center y here would be the center of rotation. And so in this case, center x would be 6, and then center y would be 6. And then we would just use these formulas right here to generate the points for the rotated ellipse. And this is what it would look like. And then now let's say I want to rotate it around the point, let's say 0, 6. Then this is what it would look like. And here I have a set of parametric equations with x equal to t and y equal to sine of t. And this is what the graph would look like. And then if we rotate it around the point 0, the origin here, then this is what the graphs would look like, the image. And then the same graph, but this time instead the center of rotation I want it to be at 0, -2. Then this is what the image would look like. And now let's get the parametric equations for the hyperbola. Recorded the rectangular equation of a hyperbola with the center at h, k, will be x minus h squared over a squared minus y minus k squared over b squared equal to 1. And then we have the identity secant squared minus tangent squared equal to 1. And so here let secant of t be x minus h over a, and then let tangent of t be y minus k over b. And then we have secant squared minus tangent squared is equal to 1. And then from here, solve for x. Then we get x is equal to h plus a secant of t. And then here, solve for y. Then we get y is equal to k plus b times tangent of t. And here I have the parametric equations. X equal to 3 plus 4 secant of t. And then 6, y is equal to 6 plus 2 tangent of t. And then this is what the graph looks like. And then I'm gonna rotate this hyperbola here around the center 0, 0. And this is what the image will look like. And now let's make the center of rotation at the point 3, 6. So here's the point 3, 6, and now we're just going to rotate this hyperbola here around this point 3, 6 right here. And so in summary, this is the this formula right here. This is for rotation at around the origin, and then if we want to have a rotation at a point other than the origin, and then we need to modify these formulas here a little bit, and these are the modified formulas right here. And that's the end of the video.